We're from Russia. Our company is AGM System. We are from Brusilo, and we provides our LIDAR system for drone, like this drone one. And they use many types of drone, like copter or plane. Yes, and Yuri now show us our presentation.
Yes, hello, my name is Yuri. I am also working for AGM system company in Russia. We provide several specific products for airborne laser scanning from drones. The first one is AGM MS3 LIDAR. You could see it in this picture. It is very light LIDAR, weight starts from 1.25 kilos, and you could install it at a lot of types of commercial drones. Because of its high accuracy, it has range accuracy 3 centimeters and spatial accuracy of the data received 5 centimeters. You could acquire high detailed and high accurate digital elevation models, 3-dimensional models of the survey area. So it's a very good solution that allows you to obtain survey data very fast and very precise. The second one solution we announced this month. It calls AGM MS1. It has a weight start from 1.5 kilos and very attractive price. The price for this solution is near 22,000 US dollars. So it's a very cheap price for a complete solution for airborne scanning from drones. This price includes all the necessary hardware, software, so you just need to have a drone and you could start surveying. Our equipment could be installed in many types of drones. So drones could be plane type or multi-copter type. If you install our equipment on a copter type UAV, you will have flight time near 20, 40 minutes, it depends on drone. But if you install it on fixed wing or VTOL type of UAV, you could fly it from 1.5 to 4 or 5 hours for one flight. So for this time, you could survey from 1 square kilometers to several tens of square kilometers. So this systems has a very good productivity. Typical workflow with our systems starts from flight planning, when you need to have a project of how the drone will fly over the surveyed territory. Then you go to the site and start scanning. The wall control of the LiDAR you could do from every device that has a Wi-Fi connection. It could be a laptop, smartphone, or something like iPad. So you just need to connect the device, make all the settings, and press the button Start Mission. After the flight, you will be able to put forth the data and get the quite accurate point cloud. You could see it on the picture as right. The controlling of the system is very simple. One button to switch it on, and several connectors to attach power and external camera and GNSS antenna. After the mission, you receive several types of data. So the data from the LiDAR, from the onboard GNSS receiver, and from onboard IMU movement unit. First of all, you need to get a trajectory solution. So based on the data from onboard GNSS receiver and onboard inertial movement unit, you will get the accurate trajectory information. After the processing of the data, the accuracy of the trajectory received is near 3 centimeters. All the processing you will do just pushing process button, because all the needed information about IMU, about its lever arm, about all the dimensions from IMU center to GNSS antenna centers is written on the data received. So you need just add it to the software and press button process. Our software allows you to analyze what accuracy will be received after the post-processing. You could see a lot of charts that show you the estimated position accuracy, the combined separation between forward and reverse processing. So you have all the instruments you need to control the accuracy you receive after the mission. After you get the trajectory solution, you process the data together with LIDAR data, and after that you receive the point cloud. On this picture, you see two types of visualizations of point cloud. On the left, the point cloud is colored by absolute height. On the right, the point cloud is colored by the reflected intensity.
Excuse me, please share your screen.
Do you see the point clouds? Excuse me, do you see my presentation? There is a picture of point clouds. Do you see it?
No, we cannot see your presentation. Please share your screen.
Спроси, он сейчас говорит, что нет скрина. Excuse me, one moment, we will consult with organizers of the conference. Okay. Посмотри, point cloud, видит?
Did you see? Do you see now?
Yeah, now we see it.
Yeah, okay. So this picture shows you why do you need a LiDAR? Why just photogrammetry is not enough? For example, here you see the territory covered by dense vegetation. Our LiDAR has possibility to penetrate the vegetation. So you will always receive an accurate digital elevation model below the trees. Where you will use popular photogrammetry solution, you will never get the elevation model below the vegetation. So it's the first advantage of using the LiDAR. The second advantage is that you receive reflections from all objects on the specific site. After the classification, you could extract from LiDAR data trees, elevation model, building roofs, some towers. So you will receive a lot of additional information that helps you after the mission to provide a very good material for different geoinformation products. The third advantage is that if we use LiDAR together with the camera, it is possible to create orthophotos without a difficult process of aerophoto triangulation. You're able to get the exterior orientation of every photo direct from the trajectory information. So you get the centers of photos and the attitude angles from the trajectory, make orthophoto transformation, and you will get the orthophotos just in several minutes after the flight, and you will not need to make aerophoto triangulation. So there is some examples of the data received by our system. Here you see the storage of sand, and our customers want to calculate its exact volume. So it has a LIDAR, and every day he flights over the territory, acquire a digital elevation model, make several calculations, and he know how much material he has at the storage. Here is example why LIDAR is a very good solution when you have a dense vegetation. On the left picture, you see orthophoto. You see that the territory is covered by vegetation. On the right picture, you see the digital elevation model. You can see that we could digitize, for example, the river that is below the trees, and we acquire its position very accurate. So it is impossible to do it just only by orthophoto without the LIDAR. Our typical procedure to make topographic maps with LIDAR, we get the point cloud. From it, we extract the digital elevation model, and then together with orthophoto and some additional materials that we could get from LIDAR, for example, intensity raster, make digitization of all objects and receive the digital topographic map. Also, with the LIDAR, you could get some additional materials. For example, this picture shows you how you can get the boundaries of a building. So you see that it is impossible to digitize it just by orthophoto, but you could get the walls extracted from the LIDAR data. This is very useful for such application like a cadastre, when you need to get the exact boundaries of the building. For example, here, one more application of the LIDAR in archaeology. Here, the example of moods that are located in the deep forest. And our customer, archaeologist, asked us to get the digital elevation model of this territory. And you see at the central picture, this mood was digitized by the LIDAR data, and archaeologists could get information about all the objects that they are interested in this territory. On South America, I know that archaeologists could find ancient cities in deep forest with this method. And my next picture shows you some examples of LIDAR installation on the different types of aircraft. This picture shows you Geoscan 401. It's Russian LIDARs that allows you to fly near 14 minutes per one flight with LIDAR and the camera. Here you can see some specification, but it's the same drone. Next picture, the most popular in the world commercial drone, DJI Matrice M600. So with this drone, you could fly near 25 minutes. It's the second picture of this drone. For example, Lufthansa, there is a lot of types of such drones you could use. The next picture shows you a fixed wing type of UAV. With this UAV, you could fly it 1.5 of an hour. So per one flight, you could survey more than 40 square kilometers. This is a very good productivity for the drone. The next type of UAV, the same fixed yes, this one. This is also fixed type of UAV, but it allows you to fly 3 or 4 hours. No?
10 hours.
10 hours. Sorry, I made a mistake. 10 hours. So if you survey 15 square kilometers per hour, with this drone, you could survey 150 kilometers per one flight. The next type of UAV is a China Joe UAV, like Joe UAV CW20. This is VTOL type of UAV. When you get off and land like a copter and fly it like a plane. With this type UAV, you could fly it near 3 hours and sway, for example, 45 square kilometers per one flight. So thanks for watching. This was my little presentation, and now Vladimir will show you our video that shows you how LIDAR could be used, for example, together with copter type of UAV, Geoscan 401, also Russian production. So here you see the installation of the LIDAR on the drone. It installed together with the camera, Sony ILCE 6000 camera. It's a little bit closer. Then when you take off, you could sway 3 square kilometers per hour with this drone. It has a scan range 200 meters, but we recommend our customers to fly not higher than 150 meters. You could land directly in the hands of operator, and after the mission, you get a very accurate point cloud. So you see an example of data. Every object here you could digitize. Also, you could see that, for example, power lines shows very precisely, like buildings, like digital elevation model, and you could get all this data by this LIDAR. Thanks, Vladimir. Let's show LIDARs. It's a live presentation of the LIDAR. It's very small. You could connect it to the drone with these 4 connections, so it's very simple to operate. You have only one button that you need to press to start the mission, and here it's a presentation of LIDAR installed on the drone.
And also you can use this type of LIDAR without drone, maybe on a car, or maybe in hands, but you need GPS antenna, GNSS antenna. And you also there is a lot of ways to scan. Some of our customers install this type of LIDAR on the car, for example, and do mobile laser scanning with this LIDAR. You also could install it on the backpack and make a pedestrian mobile laser scanning. So it's a lot of ways to use this system. So you just need to buy one LIDAR, and it has a lot of application. You could do not only airborne laser scanning, but also mobile laser scanning. And I think it's very useful, because it is impossible now to purchase another mobile laser scanning for $22,000 US. Maybe do you have any questions?